Hello everyone and welcome back to Study Room. So we have studied our first chapter of class 8 mathematics, that was rational numbers. Now in this video lecture we are going to do a quick recap, a quick revision of all the topics that we studied under this chapter 1. So let's just go back to our slide 1 and start doing the revision. So, from where did we all start? We started in this chapter from numbers. So here, this is numbers. We studied the types of numbers. First of all, denoted by capital N, starting from 1, 2, 3, going till infinity was our natural numbers. Studied about whole numbers that are denoted by capital W. They start from 0, 1, 2, 3 and they go till infinity. Then we studied about integers that are denoted by capital Z and they include all the negative numbers, 0, as well as the positive numbers, and they go till infinity in both the signs. We studied that from this picture you can see that if we add 0 to the natural numbers, we'll get whole numbers. And if we add these negative numbers -1, -2, -3 and so on to the whole numbers, what we will get? We'll get integers. Then we studied our rational numbers. Any number that is of the form p by q, any number that is of the form p by q, where both p and q they belong to integers and q is not equal to 0 is said to be a rational number. Then these are some of the examples of rational numbers, and if we include these fractions 1 by 2, 3 by 2 and so on, such fractions to the integers, then what we will get? We will get the set of all the rational numbers. Rational numbers are denoted by a capital Q. Then we studied the properties of rational numbers. The three properties were closure property, commutative property and associative property. The first closure property was if it means that a set is closed for some mathematical operation. We studied it for whole numbers and we concluded that whole numbers are closed under addition, are closed under multiplications, but are not closed under subtraction and division. Similarly, integers are closed under addition, integers are closed under subtraction and multiplication, but integers are not closed under division. And for rational numbers, we concluded that rational numbers are closed under addition, are closed under subtraction, are closed under multiplication, but rational numbers are not closed under division. We took examples for the same. Then we concluded that if a and b are two rational numbers, a plus b is going to be a rational number, a minus b is also a rational number, a multiplied by b is also a rational number. But if we divide a rational number a by 0, then what we will get? We'll get a by 0, which is not defined here, because here q equals to 0. In that case, this number is not defined and we can say that rational numbers are not closed under division. But if we take this set q star, which is the set of all rational numbers from where we have excluded this number 0, then we can conclude that in this case, on this set, the division will be closed. Then we studied about some more properties of rational numbers. Commutative property was a property in which we operate can be moved or interchanged from their position. Like the numbers can be moved or they can also be interchanged from their position and still we will get the same answer. We studied it for whole numbers and we concluded that addition is commutative, multiplication is commutative, but both subtraction and division is not commutative. For integers also, addition is commutative and multiplication is commutative, but subtraction and division is again not commutative. And for rational numbers, we concluded that addition is commutative, multiplication is commutative, and again, subtraction and division will not be commutative in this case as well. The next property was the commutative property. So again we concluded these 4 points for rational numbers. that if a and b are two rational numbers, then a plus b is going to be equal to b plus a minus b will not be equal to b minus a multiplied by b will be equal to b multiplied by a, but a divided by b will not be equal to b divided by a. Third property was the associative property, in which we said that the grouping of the numbers, the way that the numbers are grouped, it does not matter. The grouping does not matter. We will still get the same answer. So we studied it first of all for whole numbers, and we said that addition is associative, multiplication is associative, but subtraction and division both are not associative. For integers also, we said that addition is associative, multiplication is associative, but subtraction and division is again not associative. And at last, we studied it for rational numbers. In this case also, addition is associative. Here you can see that multiplication is associative, but again, subtraction and multiplication did not come to be associative in this case. So we concluded that for any three rational numbers a, b and c, a plus b plus c is going to be this. A plus b plus c, both the values are going to be same. But a minus b minus c is not going to be equal to a minus b and then minus c. A multiplied by b multiplied by c is going to be equal to a multiplied by b multiplied by c, but again a divided by b divided by c is not going to be equal to a divided by b and then divided by c. We did some examples related to these properties, and then we hopped on to the other properties of rational numbers, which included first of all the identity. In the case of additive identity, we saw that 0 is known as the additive identity because if we add any number to 0, or if 0 is added to any number, then what do we get? We get the same number. So 0 is said to be the additive identity for all the integers, whole numbers, and as well as rational numbers. But in the case of multiplication, our multiplicative identity came to be 1. It came to be 1. Why is that? Because if we multiply any number with 1, or if 1 is multiplied with any number, what do we get? We get the same number. We get the same number, and that is why 1 is said to be the multiplicative identity for all the rational numbers, for all the integers, as well as the whole numbers. What was the negative or the additive inverse? A number which when added to another number, if gives 0, if gives us the additive identity that is 0, then that number is said to be the negative or the additive inverse of the other number. So what is the inverse of additive inverse of a by b? It will be minus a by b, because if we add minus a by b to a by b, we will get 0. We will get the additive identity that is 0. Again, for reciprocal or multiplicative inverse, we saw that if there is a number a by b, then its multiplicative or its reciprocal inverse will be c by d only if a by b multiplied by c by d gives us 1. That is, it gives us the multiplicative identity. Then we came to a brainstorming question from where we concluded that 0 does not have any reciprocal. Why does 0 have no reciprocal? Because there is no such number a which when multiplied by 0 gives us 1. There is no such number a which when multiplied by 0 gives us 1. Therefore, 0 does not have any reciprocal. The next property that we studied was the distributive property. We studied about distributivity of multiplication over addition for rational numbers and also for the subtraction of rational numbers. So in this case, a will get distributed and it will become ab plus ac, and this will become ab minus ac. We did some examples related to it. We found out the additive inverse, the multiplicative inverse of many numbers, and we solved the questions. At last, what we did was the representation of rational numbers on the number line. First of all, we did the representation of natural numbers, whole numbers, and integers on the number line. And then we came to represent rational numbers on the number line. We studied how rational numbers will be written and will be represented on the number line. We also came to know that how many rational numbers are between two rational numbers, that there are the number of rational numbers between two rational numbers is not definite. Unlike natural numbers and integers, there are infinite rational numbers between any two rational numbers. And how do we find those rational numbers? We studied some examples where we found out 3, 2 or even 1 rational numbers between the given two rational numbers. So we did some examples and then we represented it, as well as we found out some of the rational numbers between the given rational numbers. So this was all that we did in this whole chapter, chapter number 1 of class 8 mathematics, that was rational numbers. I hope that everything is clear. You can now proceed to do the exercise questions by taking all these hints from the examples. Those questions are also going to be same. Let's meet in the next chapter videos. Till then, have a good day. Bye bye. Take care.